So now we want to check out the if the three group mean are same, but now we want to check out there is the group of variations are similar or like not similar. Let's take an example. I want to perform and I want to take the three data set. So let's see, I want to create imports scipy dot stats. So I want to little bit zoom it. Now I want to create the three data set, and we can also create the three data set any table. Firstly, I want to take a small example, then we can take some extra like data one. So inside the data one, we can define some data set. Like we can define some data set like the mean are different and the mean are same coincidentally. So let's see, we have the value, we can take any value like we can take 50, 60, 80, 90 and 100, 5 value. Similar, I want to take the data set to like 80, 60, 50, 100 and 40. Now the data 3, 70, 60, 40, 50, 70. So now, firstly, I want to calculate the mean. So I want to import numpy as np. So firstly, I want to create the mean. So print data 1 mean is np dot mean data 1. So 76. Now similar, I want to perform this data mean. And data 2. So now the mean of the three data set are different. Now I want to like to clear out the data similar. Suddenly I took the data 30 and 30, 50, 110. So 30 and 80. So and suddenly I want to choose the 80 and 20 and 20 and 170. Now you can see the two data set mean are different. Now I want to provide some value like 70 and 80 is 110, and obviously the 70, 60 is 110 and 100 and the 40 and basically the 30 and 70. 30 70 is 100 and like 160 and 60. So now you can see the three data set mean are same. So I am saying if the three group of data mean are same. So can we say the data are similar or different? Now the question is that. So now I want to perform the F test to find out the data variation. Variance 1 np dot var and data 1. So it is the variance. Data 2. Now you can see the variance between the data is very high, but the mean are same. So we cannot say the data are same. And 3, data is 3. Now you can see the variance of the three data group are not similar, not same. Like it is the variance. Now if we want to calculate also the standard deviation, so it depends on us. So now I want to calculate and I want to apply the ANOVA t-test. So F test, I want to pass any variable, again the two thing basically, the p value, sci p dot stats dot f one way. So f one way is a function of this stat library. Now I want to supply the all data set data 1, data 2, data 3. Firstly, I want to print the p value. So if the value is greater than 0.5, then else we accept the null hypothesis because the p value is greater than 5. If I'm talking about the F test, so there is no need to calculate all these things. There is no need to calculate this one. You can see if the null hypothesis there, that means all mean are equal. And if all mean are not equal, so the alternative hypothesis, that means we reject the null hypothesis. That is the theory. So if I will check and I will perform this one, so this say like we accept the null hypothesis, that means we can assume like all data set mean are equal. Like take an example of the subject of the marks. Like we have a three subjects and we are saying like the three subject mean are equal. That means three subject students marks are equal. So how we can check out? Like firstly we will calculate the mean of the three subject. Then we can say if we have the 30 subject, we have uh, more than 3000 students. So it is not possible to calculate all data mean one by one. So in that situation, we can pass the complete data set, number of data set into the one-way t-test, and it will calculate the p-value. If the p-value is greater than 5.5%, so we can assume the mean values are same, that is null hypothesis accepted. I hope now your doubt is clear. So I have successfully completed the ANOVA F test. I have successfully defined the ANOVA